Awesome. Next up, we have Tao from Airbnb, and he'll be talking about search of Airbnb, which they built on top of RocksDB. Surprise. There you go. Thanks, Tao.
Hi everyone, my name is Tao. I used to work for Facebook, so I'm very happy to come back here to talk about how we use Airbnb to build the real-time personalized search. So I'm a machine learning person, so machine learning need data, and RocksDB basically can store a huge amount of data and support very fast read and write latency, and also like high throughput, especially random read and write. So it's like perfectly suitable for the usage case here. So before I talk, we just want to talk about how many people had used Airbnb before, and okay, so like 10%. And how many people? Okay, I think okay, that's just. So I think if you go to Airbnb homepage, you will see some search button, search box. You click a search button, you will see results. The ranked results on the left side, the map view on the right side. So this is where the search ranking happens. So for like a city like Paris, we have almost 100,000 listings. So the ranking is important. And also on this second page, we call the search results page. You can also refine the results. If you really like the listing, you can go to the third page. We call it P3. So you can find more details about the listing, and then If you really like, you can just contact the host, and then you can request to book or send a message to the host. After you send the request to book to the host, and then the host has so you can send a message or request to book. So here you send a message to the host and ask questions. And after that, basically, the host can just respond back, like give you a different response. So the challenge of the ranking basically is like, it's very different from web search. One is like, they have two-sided preference. One is guest, the other side is host. So they have each guest has its own preference. So each user has their own preference. And behind each listing, there's also a host, the owner of the house. There's own preference. Sometimes, so if you find a very good listing, looks good, cheap, but the host may not like you the duration of your stay. And also, it's like the booking, the interaction is like the guest and the host interaction is very complex. So it's not like single click and then just like book or something. There's a lot of fun. It's a very complex data machine to control. Like there's a different outcome of that state machine. So we have to optimize the whole state machine and then try to move the user to the desirable outcome. Another thing is like the ranking is not really is the goal. So users go to Airbnb search, they spend like a week or do a lot, hundreds of search to find the good listings. So our ranking just help them, guide them through the decision process. So this like is a, and also the last one, this is a no paper. There's a new problem. Because nobody know how to solve it, and yeah, so there's a very interesting problem. So in the beginning of the year, we used machine learning to tackle this problem with some success, and it partially we tackled the first and the second problem very well. And right now, we're trying to model the third problem. Okay, sorry. Okay, now let's talk about like personalized search. What is personalized search, and then how do we use more RocksDB to do this personalized search? So what's personalized search? Basically, is very simple. The user, on the left side, the guest, they just do a whole bunch of search, and then on the side, they just do some clicks and browsing, read some scrolling, and everything. So the idea is like we real-time store all the user information to the right-hand side, a RocksDB-powered storage system. So whatever user have done in the real time, after like a couple of seconds, we will know. We will store our system and then feed back into the search ranking system. So for example, we can know whether user has. So for example, we can know like user has clicked on last three listings, or like with the price like 100 to 150. So we can show more listings like within that same price range. Or if you know the listing user has, or like look at the like modern style listings, so we can show similar listings. Or even simplest case, if we find out the user like click on one listing 3 times in a row, so the second time, if you do a ranking, we just show them in the top, something like that. So we just we build a system, like the system architecture basically is very simple. So on the left side, we have a Kafka. So the whole website, we have a Kafka log category. So it log everything happen on the website, like user what all the user activities, all the requests, user send a message to each other, whatever they're browsing, they click the images, everything. And then what we build is like we build a Kafka real-time Kafka consumer. We just process all the log. This log like is pretty big. It's like a few terabytes per day. And then we build the Kafka consumer, and then we process all the log and the real time right into RocksDB. So the QPS, the write QPS is like very high. It's like thousands, tens of thousands, thousands per seconds. So that's why we choose RocksDB, because a lot of things is a random write. So we want to support this throughput. On the other side is the search engine. We build our own search, have to talk to RocksDB to fetch the data to power the search ranking. Because also I think Pinterest talk also talk about like RocksDB does not support master and replica, and in some scenario where we need the stronger consistency, we also build on top of like RocksDB Zookeeper, and we hack our own version of like master and replica. So it's all transparent to the application. So application just send the user ID to the just to a machine, to a master, and then they always know which master it is, and then they will automatically handle the replica data to the slave, and then back and forth. Everything is through Zookeeper and stuff. Yeah, that's a leader election and all that stuff. Yeah, I think. It's like doesn't matter. But basically, the magic we just handle some like really try to increase the reliability, and then I think basically everything. Yeah, we launch the production and everything. If you go for the user who use Airbnb, if you log in, you do search, you will see the difference. You do the first time you do some search, you click on something. The next time you see different ranking results, everything, and then increase the booking, and it's all the good stuff. Yeah, so I think the summary basically is like, RocksDB is good for web scale, like service. If you want to bring intelligence to your serving system, they can store a lot of data. They can hide, especially for real time. For like just read-only data, there's a lot of other choice. But for like real-time read-write, I think RocksDB seems to be the best choice here. Yeah, I think that's all. Actually, not in the Airbnb. Actually, I also so in my previous company, we used Tokyo Cabinet before. So Tokyo Cabinet, so there's a pros and cons. So right. Oh yeah, so basically, so we have our own like I think there's open source. So the open source project is called Synapse. Facebook has something similar. So there's service lookup service. It's all transparent. There's some name node. You just talk to that name node, and then they will automatically find out which one is the master, and then they hide away master and slave difference. Yeah, it's also Zookeeper based. Not in this case. It's not in the user personalization. So we also store some like real-time statistics for each listing. So it's like how many times user have looked at this listing, how many times they make contact this listing. So we don't want user will come up at like different time, different day. So we have much stronger consistency in that case, because this is like directly we show numbers directly facing to the user. So in that case, we build this one. For ranking purpose, actually, it's fine. We don't need the very strong consistency. Yes, actually, so it's configurable. So right now, basically, because there's a very high I/O, so we don't want to. We will put out the same machine. That's I think that's a very good question. So I think there's a different use case. So for the real-time personalization, so we only look at the past 2 weeks. So because we believe only the recent behavior affects your ranking. So that one we just have we have a chrono job to clean up the key. Yeah, because the zookeeper. Okay, so basically we have a master and the replica. So the zookeeper will tell us, and then basically, yeah, the logic there's some complicated logic. No, this is the theoretical. Yeah, so the idea is like every once in a while, so the master will just replicate data, just like create a new backup, delta backup and then they will do the delta sync to S3, and then periodically replica just load the replica to the master, and once they detect downtime, just read it. And also we have some logic for the Kafka. There's also they can take. We also store the Kafka offset, so we can make sure that we don't miss data. Yeah, right now, yeah. Okay, so yeah. So okay, RocksDB basis, so we can go pretty far away. So it's like two, yeah. Okay, so basically, so the whole idea is when we create delta, when we create backup, we also store the Kafka state. So Kafka is some API we can store like how far we have consumed the data. We store all the state and the backup state automatically into Zookeeper, and we use Zookeeper to. Huh? No, we only store the metadata, the Zookeeper state, the Kafka state, like what offset within the Kafka. Snapshot owns everything's metadata. The snapshot, the version number, the path, and everything. Yeah. So basically, so every time we take a snapshot contains both the RocksDB storage and the Kafka state. So every time this startup, just check the current version of my version versus the whatever the Zookeeper version. No. So yeah, I think we guarantee we don't miss data, but we can process data multiple times. Okay. Any other questions?